bandwidth, and that is called a jammer. But obviously, jammer cannot be planted everywhere, right? It's costly. So you plant it maybe at a certain location. That's why jammer is directional to you as a radar. You follow? So the jammer may come in from a certain fixed direction. And that is what is being described here in terms of power spectrum in a 3D plot. Alright? So this is your angle axis, frequency axis. So therefore, you see you have a power spectrum with uniform distribution across the complete frequency range, but from a particular direction. Therefore, from this plot, you know this is a jammer. And as for target, well, it is from a specific direction. And it is because it is from a specific direction at a certain angle from you. So though you are traveling at a certain speed, the Doppler return will be a fixed frequency, right? Not covering the whole bandwidth, but a certain specific frequency. So to resolve this problem, we use the step processor. And basically, this is the structure that you see earlier on. So the plot here is basically the same as what we had earlier on. Antenna, and then you have a FR filter, antenna, FR filter, antenna, FR filter. Alright? So multiple antenna and multiple taps. Okay, this is basically showing you the, you don't have to memorize anything. You can skip all this actually. I include this is because these three guys, R and B, they proposed and they proved that it is possible to use a space-time structure to solve the radar problem. Alright? So who are the three guys? These are the three guys. Ray, Mallet, and Brennan. That's why R and B. So the algorithm they use to calculate the weight for radar application is therefore known as the RMB algorithm. But this is something done through computer simulation. Theoretically, it works out, but in the practical situation, well, you have to do much more than that, right, to implement your step processor. But their key contribution is this. When you have, let's say, 10 antenna in your implementation, you have to make sure that, roughly speaking, if you have 10 antenna, then you have to make sure that you need to use at least 20 snapshots in your calculation of the array weight. So that is the meaning of this statement, and I call it the rule of thumb from RMB. So that is a practical rule of thumb. So if you have 100 antennas, then you have to do sampling of how many samples to obtain how many samples, 2 times of the number of antenna. So if you have 100 antenna, then you have to at least collect 200 snapshots to form your covariance matrix. And a covariance matrix practically is done this way. So this is again your data cube, alright? So this is something that you have not seen. What you have seen for your Doppler processing is you have in the previous slide. So we have a 2D data structure, but for this case, well, you have your range beams. So this is your fast time, and then you have your slow time axis. Right, so here we put bracket CPI. This means coherent processing interval. Right, so this is something that you have done in when you learn Doppler processing. Right, so you may roughly interpret this as within this interval, the target scenario is more or less no change. Right, and therefore you use the same the PRM. Right, the pulse repetitive frequency. So within that interval. So that is an assumption. Okay. So if the target scenario changes too rapidly, then obviously this will not work out. Okay. So there is an assumption. This is a so-called CPI, coherent processing interval. And vertical axis here is the array elements. So this is the new dimension we introduced when you talk about array. So from here you can see that every beam actually corresponds to a data of this size. So this will be the number of antenna elements, and this is the number of houses. So to form your covariance matrix or to obtain your snapshot, that's what we do. For each value, well, we have a column to form part of the vector. The subsequent column, we append it below. The next column, append it subsequently. So this, though you don't see dot 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 here, so between the pink and the blue, you should have 2 more columns from here. Follow? And from blue to yellow, you should have 1, 2, 3, 4, 5, 6 more columns inserted here. You follow? So that's the meaning of dot dot.